How to do a simulation. This is a four-step process. First of all, we need to ask a question of interest about a chance process that we want to answer using our simulation. Then we have to describe how we're going to use a chance device to imitate one repetition of the process and what we are going to record at the end of each repetition. In other words, what's our response variable? Make sure the probability of an outcome using the chance device equals the probability of the actual event. That's very important. Third, then we perform a lot of repetitions of the process, and we use that to create a sampling distribution, and then make a conclusion based on our simulation. So examples of chance devices, it's the random number generator on your calculator, the random digit table, as you see below on the paper. It can be something as simple as tossing a die. So tossing, that doesn't say tossing, I don't know what that says. Tossing dice, or flipping a coin. Those are all random chance events. It could also be drawing numbers or names from a hat. All of those examples are random processes that we can use to do a simulation. So we're going to look at a specific example using a random digit table. So here is the scenario. On her way to work every day, Eliana passes through an intersection with a traffic light. The light has a 1/3 chance of being green when she gets to the intersection. One week she was frustrated because the light was red every single day, 5 days in a row, when she got to the intersection. How unusual is that? So here's our question that we want to answer. How unusual is it, or what is the probability of getting 5 red lights in a row if the probability of a green light is 1/3? So let's write our question. So we want to know what is the probability of 5 red lights in a row. Now, our given information here is that the probability of getting a green light is 1/3, so that means the probability of a red light is 2/3. So specifically, we want to define an event. We're going to say x equals getting a red light. And we want to know that the probability that is that x equals 5 in a row. Okay, so that's what we're trying to find out. So we have to clearly think about what it is that we are asking. Secondly, we need to plan. We're going to use our chance device. We're going to use a random digit table. When we use a random digit table, or whatever random process we use, we have to make sure that the probability in our simulation matches the probability in the problem. So I have a 1/3 probability of getting green and a 2/3 getting a red. So somehow I have to model that 1/3 green, 2/3 red using numbers on this table. Well, the easiest way to do that would be to use as many one-digit numbers as I can, which in this case would be 9. I could use 9 of the 10 one-digit numbers. So I'm going to say this, for the green light, to represent the green light, I'm going to use 1 through 3. 1, 2, and 3. For the red light, I'm going to use 4 through 9. 4, 5, 6, 7, 8, 9. So there's 3 numbers representing green and 6 numbers representing red, which gives me the 1/3 and the 2/3 chance of getting a green or a red. And then I'm going to ignore 0. So I'm not even going to count 0 for anything. Anytime I see a 0, I'm just going to skip over it. And then I am going to choose 5 random numbers in a row on the random digit table. Skipping over zeros, because I don't want zeros. and record the number of red lights. So in other words, I'm going to record how many times I get the digits 4 through 9. Now at the end then, so when that's my process. So number 3 is I'm going to do the process now. Now I'm going to assume that so I'm going to just say start at the beginning. Oops. Start at the beginning of the first row. And continue until I run out of numbers. Now this is a short random digit table, so continuing until I run out of numbers makes sense for 3 lines. Most of the time you'll say and do 20 trials or do 30 trials or something like that. And continue until I run out of numbers. Okay, so I'm going to go through a couple of these with you and then let you continue on so you don't have to sit there and watch me do the whole thing. But okay, so starting here, I see 7, 4, skip over the 0, so 7, 4, 4, 1, 4. So that's my first group of 5 numbers. At the end of every trial, I'm going to draw a large vertical line so you can tell that's my group of 5 that I'm doing. So if I look at these numbers, 7 and 4 both represent red lights, 1 represents a green light, so I got 4 red lights here. Okay, then I'm going to skip over the 0, count 2, 6, 2, 9, 9. That's my next group of 5 digits. Now you might be thinking at this point, oh, you're not skipping over repeated numbers. What about the whole thing with repeated numbers? We always have to skip over repeated numbers. We skip over repeated numbers if the numbers represent individuals that I am sampling without replacement. In other words, I'm not putting them back. But if my numbers represent probabilities rather than individuals, I do not have to skip over repeated numbers. I'm just saying, what's the probability that at every light, it's kind of like an independent event every time. What's the probability that I'm getting a red light? So each number just represents getting a red light or not every time, and it doesn't say that I'm running out of red lights and I have to take those out of the mix. So in the past, when we were doing sampling and we were using the random numbers to select a sample, we had a limited pool of individuals, and every time we selected one, they were removed from that pool, so we had to skip repeated numbers because of that. That's very important to remember. Okay, so having said that now, 2 and 2 and 3, 9. So I have 3 red lights now. Okay, so I'm going to do another group of 5. 1, 6, 2, 6, 6. 1 and 2 represent green lights, so I have 3 red lights. 3, 6, 1, 8, 2. So I have 3, 1, and 2 are green lights. 6 and 8 are, 3, 1, and 2 are green lights. 6 and 8 are red lights. Okay, I want you to continue. I'm going to continue also, and then I will turn the video back on. Now I finished marking my table. Notice this 5 here I carried over to the next row and did 4 more numbers. It's possible that just out of carelessness or whatever, your numbers may be slightly different than mine. I think mine are correct. I possibly could have made a mistake too. But what I want to do now is I want to see how many 5s I have. So here's one time I got a 5. Here's another time I got a 5, another 5, another 5. I think that's it. And how many trials did I have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So my results are here, then, let me see what step 3 says. Oh, that's my step 3 is my performing many simulations of the trial. So step 4 is what is my conclusion? Well, let's write down the results here before we actually do the conclusion. So the results are 4 out of 28 times. 4 out of 28 trials had 5 red lights. Now, I could actually do a distribution and do like a dot plot and show how many of the, what else is likely to happen. So I could see like how many times I had 2s, how many times I had 3s, how many times I had 4s, how many times I had 5. That would be the distribution of the results, making a dot plot of that distribution, and that might be useful to see not only how many times you have red lights, but sort of what is the expected number of red lights. But for right now, let's just answer the question is, how unusual is that? So that means, so based on the simulation, based on my simulation, there is about a 4 out of 28, or, and this turns out to be 14.3%, 14.3% chance or probability of getting 5 red lights in a row. This is somewhat unusual. This is somewhat unlikely, but not completely unusual. This occurrence is somewhat unlikely, but not unusual. I'll say, but not terribly unusual. It's going to happen about 15 times out of 100, so it depends. You consider that unusual or not. Yes, somewhat unusual. Oops. Well, it looks like my problem is, there's a problem here with my notebook, so I'm going to have that. I couldn't finish writing what I needed to write. Well, my notebook completely crashed and lost all my previous work, but I just wanted you to get the actual conclusion here, which probably needs to be at the bottom. But basically, here's the conclusion. Given that the light is red 2/3 of the time, so we do have a given here. My simulation recorded 4 out of 28 trials with 5 red lights, so Eliana will get red lights all week about 14.3% of the time, which is somewhat unlikely, but not terribly unusual. So there would be the conclusion that we could draw from this simulation.